So this is an early version of our hopper. This was actually version 1.0, something we scrapped.
Yeah, well, this is the initial phase of the marble sorter. And one of the things that this is designed to do is that it's going to pick up one marble at a time and send it down to the chute for it to be sorted in the next second and third phase of the build. And right now we're testing it and test A-OK.
All right, it's been okay. Now we're live.
Okay, so one of the first things we're going to do to sort the marbles is to decide if they're metal or not metal. To decide if they're metal, we'll just use them basically to complete the circuit going from here to here. Putting the metal on acts as a switch, like closing a switch, and so it will conduct. If you look at the sensor here, and if you look at this one here that says limit switch, when I put the marble on, it goes to 1. When I take the marble away, it goes to 0. 1, 0. So that'll be our first testing. If it's metal, the motor will turn, and the marble will roll down into another sorter that will decide what kind of metal it is.
Okay, so one of the problems we just realized is when the balls hit this conductivity tester, I can't see my finger, conductivity tester here, and this tries to rotate, it's going to run into the walls here, so we're going to try to modify these distances here, so be back. Okay, so Mr. Osuna, how you doing? You're gonna, if you could please explain to us your mechanism, how it fits into everything, and where you're at.
Alright, so this is basically the part that's going to sort between steel and aluminum, or wood and glass. So when the ball comes down, we're going to check if it's metal or non-metal, conductivity. So if a metal ball drops on here, then it's denser than the aluminum ball. So the steel will drop down into a Dixie cup that's going to be down here. The aluminum will travel forward and be dumped off on the other side. If it doesn't conduct electricity, the servo is going to turn our sorter this way. If it's glass, it's denser than wood, therefore the glass will make this teeter this way and drop here, and wood will go across and finish off at the other end.
Good stuff. Nice. Alright, so this is our initial test here. As you can see now, we've put all three parts together. Well, I forgot what they're called. This one is called
Sorter.
This is the sorter.
Conductivity
this
tester.
is the conductivity tester, and this is the marble mover. Yeah, modern marble.
Okay.
All right, here. So balls start here. Little conveyor belt turns. Puts balls through there. Hits this conductivity tester. You can see there's two wires hooked up on either side. If it sorts non-metal and non-metal. If it's metal, then you have an electrical connection, which is these jumper wires are connected here to our Cortex controller, which sends a signal, and then it goes here to our sorter, which is going to dump them into some bins here. So that's the idea, and I'll be back in a second with our first functional test.
All right.
There you go.
Action.
So this is our new edition. It's Red C. We tried using the wheel here, but the flexibility didn't allow for different sizes and it will notch. So we're going to try a rotation in which we'll spin the servo motor one way to release the ball, and this will catch the back ball. From there, I'll load the ball, unload, load, unload, and we'll go from there.
Can I just
Go, DB.
Let's die.
Okay, I'll cut that out. Here we go. Functional test. Whoa. See that ball?
Okay, that first one is always going to do that. Whoa.
Yeah.
Safety hazard.
+2 also.
Okay.
Oh,
Which ones are
he's getting pelted here.
Okay, I know what happened. Okay, then we can stop it. There you go. We can stop it. We just need to reduce the space here. Reduce the space by just a little bit. Reduce this by one more. Instead of putting this, we could put a black one, right?
Okay. Glass. Aluminum. Oh. I'll try that again. Okay, steel. Wood. Glass. Steel. Aluminum. Glass. What if we still have a little too much speed? It's more speed right here. Might have to tap it. But generally, it's demonstrating the concept very well.
Action.
So this new attachment that we made is to support, to catch the glass. When the glass comes down this chute, it will hit on this catcher right here, and this will guide it to this second. Anyway. See, because you tell me I'm on camera I get all anyway, so
Second ramp.
the second ramp, it will guide it down to come down this first ramp, they hit this ramp, and then the glass will fall on this ramp, and then it will direct it into the bin here.
And go ahead.
So without this ramp, then what happened is that the glass will not push this ramp down all the way down, and then it will just fly. Would not hit the bin. So for it to hit the bin, we added this ramp.
All right.
Oh, this is falling apart.
Poetry in motion.
Metals. So, are you sure though that when this thing comes rolling out of there, it's going to land where it's supposed to? Or when it lands there first and then it conducts it and it flips, it could throw the thing clear.
Right.
Seldom is heard a discouraging word.
Yes. So that's we're gonna have to test it.
So you're not ready? It's not appropriate. We didn't claim.
Hey, Mike, why don't you go help somebody, man?
Some people over on the other side.
Here we go. This is our teacher, the naysayer.
Really helpful. I'm being realistic.
I know. We're gonna test it. Don't worry. We're gonna be a good engineer.
We just put all the modules together.
Just put it together.
Okay. It's on more than one base plate. Go ahead and build that one.
Yeah, we have.
More than one base plate.
It's covering more than one base plate. That's okay.
We're using one base plate.
We're only using
One base plate. Yeah,
It's okay for the overall size.
We didn't steal. On your own? Yeah, it was kicking it out. Because it was pushing everything back. Okay. So just a
The
delay.
only thing is that while this is doing this, we're not able to process the metal detector. So let's run some steel ones.
Okay.
Because the question would be,
Stuff is coming apart.
where will the steel one be when this thing comes down and is ready to move on in the program?
So we gotta get the delay somewhere.
So this is a functional test
See how it goes back? Push it back.
of our hopper. This is version 4. I don't know if you can still call it a hopper, but I guess so.
Nice. Yeah, right there. Right.
Looks like we lost one.
Thank you, Jessica.
As you can see, we've got some
Oh, cool.
metal posts there to keep the balls from flying out.
That's an improvisation right here. Yeah, we got it, guys.
So the way to
So here is our final functional test. As you can see, our teacher is
You
loading.
want to explain to the class how this thing works while I load this up?
Alright, so our program, we do one marble at a time. What we did is this is a continuity
conductivity tester.
Conductivity tester, right? So basically it's going to do metal and non-metal, right?
Yeah.
So when the metal ball goes on here, it closes the circuit, causes the servo to turn, places it on here. The aluminum has low density, so I'll throw it out here. The metal high density will flip this one and put it here. And then when there is no conductivity, then the glass will come here. It's heavier than the wood, so it'll drop down this ramp to the back, and then the wood would just flow all the way through.
Before you start it, explain how you're using the controller, the Cortex controller, to determine when that's conductive.
Yeah.
I mean, how does it know that it's conductive?
Digital out.
Digital in, digital out, I mean, like,
So there's two wires here. There's two
wires,
jumper wires,
two jumper wires
that are
here.
stripped on the other end, and they're connected in. We just strip the wires and put them in the digital inputs.
so you're using it as a, what kind, you just bumped this, I hope that didn't screw up the whole thing. What does it mean? But, I mean, how do you, what kind of sensor do you have it as in the program?
Is it a limit switch?
Basically acts as a switch. Acts as a switch.
Switch.
So when it's conductive, it's reading a 1, say, and when it's not conductive, it's reading a 0.
I just bumped this.
Okay.
Because that's how you test it.
You think it'll still work?
It's okay, man. It's only the time we have
I think he's freaking out.
Putting the conductivity of the...
Good. Yeah, so hang on a second. So there's a current going through that all the time.
So there's a gap. The only time that it actually closes, right, or reads 1, is when the metal ball or aluminum ball hits.
That's the key right there.
Yep.
That's the key, is the gap. The gap
Yep.
is closed when a metal ball is...
Exactly.
Metal or aluminum.
And then, because you've got that
You don't have metal
clip
touching
and that
metal.
clip,
Right.
so you've completed the circuit
So
when
is
a
it-
metal ball is
Is it
on.
true gap? There's
Yes,
nothing
it is.
connecting?
Yes, there is a gap there.
There's some space.
I'm
So
on
there's
the
only-
remote.
That's really good. Okay, whenever you're ready.
So, I think this is our official video, our official final version. So, here's our teacher, our illustrious instructor,
Hi.
loading up, he's such a ham. Hammy,
Turkey.
yeah, see? Alright, he's loading them
There's your
in
16
random
balls.
order, 16
Balls
of them.
are loaded.
Here we go.
Whenever you're ready, Mr. Electrical Engineer guy.
There you go. Number 1, successful. Number 2, successful. That's good. Okay, I'm gonna be quiet.
Take another one out.
Nice. Oh, Marco.
You didn't see that.
Nice.
And they do the X-ray of your mouth. Like, open wide, do this.
Crap.
You have to call bank shot.
What's interesting is that some of these metal ones, it takes a little bit of time for it to register because it kind of bounces, and when it's bouncing, it doesn't complete that circuit until when the thing's like halfway down. See, that one was fine because it didn't bounce. I noticed a couple of them have bounced quite a bit.
You could always just drop that down a little bit.
Yeah.
In fact, it would have been really easy to mount the whole thing on the one below it. Was there actually any liquid in there?
What happened?
Put a copy on it.
I don't think I made any mistakes. There
That's all the ball. No, everything went in.
you go. Very nice. Okay, while